as you may or may not remember, all experiments have variables. There's 3 different types of variable. We've got our independent variable, dependent variable, and we have control variables. Okay. I'm going to explain the experiment to you, and then I want to see if you guys can match the correct variables to the description. So what we're going to do is kind of a real world situation. If you ever go bungee jumping, they ask you how much you weigh. They need to know how much you weigh because they need to know how many bungee cables to attach for you to fall without hitting the ground, but actually fall far enough, especially if you're over a lake, that maybe your head dips into the lake, but you don't go smacking into the lake.
I want to go smack.
Okay? You don't want to go smacking into the lake. So they need to know exactly how many bungee cables to give you and the person you're going with so that you have an appropriately safe ride. Now, we're going to be doing the same thing. Your data needs to be accurate because you're going to get one chance at the end to compete in the Barbie Bungee challenge. I'm going to have a distance, I might say 40 feet. The drop is 40 feet. To get 100%, you're going to figure out how many rubber bands you're going to tie to Barbie's feet, or how long the bungee cord needs to be for Barbie to fall 40 feet, not hit the ground, but end up 1 meter or less from the ground. So to get full points, Barbie has to fall somewhere between the ground and 1 meter, and then bounce back up. If you collect good data, it's not all that hard. If your data is bad, often what happens is your bungee cord is too long and Barbie's head smacks the ground and you end up as a dead Barbie. That was my score when I did it. I thought I had really good data. And I did think I had good data, and it was pretty close. Her head touched the ground, still gets a 0, even though it didn't really smack the ground. She has brain damage. She just didn't die. I should probably say brain damage Barbie instead of dead Barbie, because mine barely touched. So I'd had a 90% on my lab if everything else was perfect. Still an A-, but 10% of your grade is going to be based on how good and accurate the data you collect is. Okay? So, with that in mind, we have an independent variable. Does anybody remember what the independent variable in an experiment is in general? It's the thing that
Is independent.
Oh, it stays the same. Right?
Drive.
What are we
Jaden.
talking about?
Wait. Drive.
Are we talking about independent?
It's
we're
the
talking about
x-axis.
independent variable. Huh?
It's on the x-axis.
It is on the x-axis, but that's not telling us what it is. That's telling us where we graph it.
It's the one that changes
It
constantly.
is the one thing in the experiment that we're allowed to change. Okay, it's the thing in the experiment that changes. And in this experiment, when we're collecting our data, what is the one thing we're going to change?
Bungee cables.
Huh?
Bungee cables.
The number of rubber bands, or bungee cables. We'll just call them rubber bands in this case. So the independent variable in this experiment is the number of rubber bands.
Maybe a lot of rubber bands.
The dependent variable, you never know. Maybe I'll say, well, it's only 10 feet that it's got to drop, and then you wouldn't need as many rubber bands, right? The dependent variable is the thing that we're measuring in the experiment. I should have asked you guys for that, but I'll just give it out to you, apparently.
So what's the control variable?
I'll get to it in a second. So, the dependent variable is the thing we're measuring. What are we measuring in this experiment?
How far she goes down.
Number of rubber bands.
Nope.
How far
That's
she
what we're changing, right? We're changing the number of rubber bands. We're measuring, Christian,
How far she goes down without getting brain damage.
how far she falls, right? So the distance of the fall. So our dependent variable is what we're measuring. And we're going to be measuring the distance of the fall. Control variables are all the other things in the experiment that we have to keep the same for it to be a fair experiment. Okay, so these all stay the same. So, an example. If I were using rubber bands, would it be a smart idea to use some short, skinny rubber bands and some real long, fat rubber bands and some short, fat rubber bands? What do I want to make this a fair test?
Same type of
I want to
band.
use the same size and type of rubber bands so that it's a fair test. Otherwise, it might be it only takes 10 big long rubber bands to get to the bottom, but it might take 40 short little ones. It'll mess up our results. So to make it a fair test, we want to use the exact same type of rubber bands. Okay? You'll probably want to use the exact same Barbie doll. I'm not sure. Maybe one of these is taller than the other. Yep, Ken is taller.
That's also Nick.
Okay? That will make a difference in our results. If you want to just barely hit the ground and you don't keep taking into account that Ken is 1 inch longer, maybe your Barbie hits the ground when it would have been perfect with the other one. So you want to, whatever Barbie doll that you're doing your testing on, that's the Barbie doll you want to do on the challenge. For all I know, one of these weighs more. I'm guessing Ken weighs more than Barbie.
Ken's fat.
Okay? To be fair and to make it an accurate test, you want to use the exact same Barbie doll. That's what control variables are. They're the things that need to stay the same to keep the test fair.